A very good afternoon, Ananda. Last class we discussed the introduction of digital signal processing, and later we discussed the concept of standard signals and how it will be helpful to calculate the complexity of programs. Today class we will discuss the concept of classifications of systems. And at the end of the session, you know the definition of system and its classifications, and the classifications of discrete systems. So already continuous signals we learned in our signals and systems. So first and foremost, the definition of the signal. The definition of the signal. A system is defined as entity that acts an input signal and transform into an output signal. Means first and foremost, system is that you have to give in a signal. That signal will be transformed to another signal. So simply with that definition, we can pronounce that system is nothing but a conversion of the signals. The system may also define as a set of elements or function blocks which are connected together and produce an output in response to an input signal. The actual physical structure of system determines exact relation between input and output. So such as mirror, filter, motor. So if the signal, if I will apply some signal X of t, that will be converted as another signal. So simply signal conversion, signal conversion. If the signal conversion, if the signal conversion is nature of continuous, that is the continuous time system. And the similar way, if the nature of the signal is discrete, and to convert the discrete signal, one type of discrete signal to another type of discrete signals, and that nature we can call as a discrete time systems. So basically, we have different types of signals. We have the thing that we mainly concentration on that signals. One is the static and dynamic systems, causal and non-causal systems, linear and non-linear systems, time invariant and time variant systems, and stable and unstable systems, invertible and non-invertible systems. And obviously, we have another types of systems that is called as FIR systems we have, and we have IAR filters. We have. Now we will learn one by one systems and to learn one to one object. The first system we know that static signal, static system. So static system means the present output, present state or present output or output depends only on present input, only with the main important. So six, what's the static system definition? Present state, that is the present output depends only on present input. Let us take one example. Phi of n is equal to x of 2n. So here the present state depends only on present input. So let us take, to solve this one, let us take n is equal to 2. Substitute in n is equal to 2, y of 2 is equal to x of 4. Means the present output is 2. It depends on future value of input. Present not depends on present. So as per definition, it will not satisfy. So it is not a static. So another system we have that is called as dynamic systems. Another system we have dynamic systems. So what is the dynamic system? The present output depends on present as well as the past also, future also. That is means if the system is not static, then it is the dynamic. Means what? Present output depends on present input, future input, as well as the past input. So simply it is the dynamic. So likewise, for an example, if I will take y of n is equal to x of minus n input. Let us take simply n is equal to 2 substitute. Where n equal to substitute, you will get y of n is equal to x of minus 2. So the present output not depends on present input, it depends on past. As per definition, it is not static, so obviously it is the dynamic. So all you should remember, all differentiate signals, differential systems are dynamic. All the differential systems are dynamic only. And the next signal is the same signal causal and causal systems. Causal and the same study what we earlier for the static, the same way here also will be different. So first we learned causal system. What do you mean by causal system? Causal system means present output depends on present input as well as past input also. That means in previous case for static system, present output depends only present input. But here, present input depends on past input also. And obviously non-causal, which is having non-causal means present output depends on present, past as well as future also. Let's take some examples. Let's take one example. Example one is, for example, x of t is equal to y of t square. So where x is the output you can consider, y is the input you consider. Let us take t equal to 2. Means x of 2 is nothing but a y of 4. So present output depends on future. It is the non-causal. Not everything is true. Solution. So we have to do some fun. So for an example, y of n is equal to x of minus 2. So where you will take n is equal to 2, you will define. So for example, n is equal to 2, you define n is equal to 2. So y of 2 is equal to x of minus 4. Means present output depends on previous. So it is a causal condition. So the system is causal. But we don't decide it is the causal. Why? Because of if you take the for this type of problems, like you have to take n is equal to 0 and substitute n is equal to some negative value and substitute n is equal to some first value. In three cases, you will get the causal, then the system is causal. Right? In three cases, system is causal. So for an example, n is equal to, if you substitute minus 2, where you will get y of minus 2 is equal to x of 4. Means what? Past present value depends on which. It is not a causal. It is not a causal. So the system means that. So please keep in your mind in the scenarios. And then just we discuss about the linear properties, linear and non-linear. The required problems we will discuss later class. What is mean by linear? A linear system which is following the principle of superposition. Superposition principle which is followed, the system is called superposition. The system is called linear. What is mean by superposition? Superposition principle is always follow the law of homogeneity and law of additivity. It maintains the two philosophies, that is the law of additivity, law of homogeneity. So law of additivity means what? Whatever the output you have to be added, the same thing will be applied to the output side. So law of additivity, law of homogeneity means whatever the number you have to be multiplied to the input, the same thing will be reflected to the output. Law of additivity and whatever the objective we can add inside the input, the same thing will be reflected to output side also. Let us take two examples, x1 of n as well as the x2 of n. Let's for an example where you get x1 of n and x2 of n. There you will get the output as y1 of n and y2 of n. So here I just multiplied with the a. Here I multiplied with the some p. Similarly, if I multiply with the a, I will multiply with the p. So if I will be perfect with plus, so both will be same. Simply what? A into x1 of n plus b into x2 of n. This is simply equal to a into y1 of n plus b into y2 of n. Means whatever the objectives we will be multiplied, the same thing will be reflected to output. So the input and output. So if the any system will be followed this, and it is called as linear. If it is not followed, it is called as non-linear. So next class we will discuss impulse response. Next class, before we go into this. Next class we will discuss some other remaining topics, and then we will go for the